In this video, we're going to look at solving absolute value inequalities. Similar to solving an absolute value equation, when we're talking about distance, we can go in either direction. So we're going to set up oftentimes more than one, or at least a compound inequality to solve these. So our rules, again, if a is greater than 0, then the absolute value of x being less than a is equivalent to negative a is less than x is less than a. So in this situation, we're basically just saying that whatever x is somewhere between that value of negative a and positive a. If the absolute value of x is greater than a, then that's equivalent to saying that x is greater than a or x is less than negative a. And we're going to see what this is visually on some of these examples. Just like with absolute value equations, we do want to be conscientious of the fact that x and a can be expressions of multiple terms. The steps for solving an absolute value inequality, we want to isolate the absolute value just like we did with an absolute value equation. We're going to apply the absolute value property, so one of those two rules above, and then solve each inequality or the compound inequality. So a compound inequality is where we put it all together as one for that less than type statement. And these are the two separate inequalities. Solve each inequality and write the solution set in interval notation. The absolute value of 3x plus 2 is less than 5. Let's think about what this means visually. What this is saying is that this expression 3x plus 2 is fewer than 5 units from 0. So here's 0. Negative 5 is exactly 5 units from 0. Positive 5 is exactly 5 units from 0. So this 3x plus 2 is going to be some value between negative 5 and 5. But we're not going to include those two endpoints because those are exactly 5 units and we have to be less than 5 units. So this is visually why we set it up. Negative 5 is less than 3x plus 2 is less than 5. Quick review of solving compound inequalities. Whatever we do to isolate that variable, we're going to do to all parts of that inequality. So we're going to start by subtracting 2 from all sides. Negative 5 minus 2 is negative 7, less than 3x, less than 5 minus 2 is 3. And now we're going to divide all sides by 3. So we have negative 7 over 3 is less than x is less than 1. When we write this solution in interval notation, that's going to be from negative 7 over 3 to positive 1. We're going to use parentheses on both of those endpoints. Three times the absolute value of 5 minus 2x is greater than or equal to 3. Starting with isolating the absolute value, we're going to divide both sides by 3. So we have the absolute value of 5 minus 2x is greater than or equal to 1. Be mindful whenever we're solving inequalities. Remember that we have that rule that if we divide or multiply by a negative number, we have to flip the direction of that inequality symbol. In this case, we were dividing by positive 3, so nothing changed. But just a quick reminder. All right, so let's think about what this is saying visually. What it's telling us is that this 5 minus 2x is more than 1 unit away from 0. So we have our self-centered at 0. Here's positive 1, here's negative 1. Both of those are exactly 1 unit from 0. So this 5 minus 2x can be 1, or it can be anything more than 1, because everything more than 1 is going to be more than 1 unit from 0. So that's the 5 minus 2x could be that portion. Thinking about the other side of our number line, this 5 minus 2x could also be anything less than or equal to negative 1, because all of those values are at least or 1 or more units from 0 as well. So when I look at those rules, okay, it's at the very top of this page here. If absolute value of x is greater than a, That's equivalent to x is greater than a. So that 5 minus 2x is greater than, and in this case, greater than or equal to 1. Or x, or the 5 minus 2x in this case, is less than or equal to -1. Now we're going to solve each of these inequalities separately. For the first one, we're going to start by subtracting 5 from both sides. So we have -2x is greater than or equal to -4. Sorry, -4. Sorry, I'm looking at the wrong part of my work. And we're going to divide both sides by -2. When we divide both sides by -2, we want to make sure we flip that inequality symbol. So I'm going to go ahead and do that first before simplifying the two sides. We're going to be left with x on the left, and -4 divided by -2 is +2. So this gives us the set x is less than or equal to 2. Now let's solve the second inequality. We're going to subtract 5 from both sides. So we have -2x is less than or equal to -6. Again, dividing both sides by -2. I need to flip that inequality symbol, so let me do that first, and then simplify. We have x is greater than or equal to -3. Oh, I made a typo. That should be a -2, making this a +3. X is greater than +3. Now, it might help us to see this on the number line just to set up our interval notation. So below my setup, I'm going to set this. Here's 2, here's 3. They're saying that x is less than or equal to 2, so that's values to the left of 2, including 2. X is greater than or equal to 3. That's values to the right of 3, including 3. And because this is or, we're looking at the union, so we're including both of those intervals. So the first interval goes from -infinity to 2. Union, the second interval starts at 3 and goes to +infinity. Absolute value of 2x plus 1 over 3 is greater than 5. We're going to set this up just like we did that previous example. We don't need to isolate. It's already done for us. So we have 2x plus 1 over 3 is greater than 5, or 2x plus 1 over 3 is less than -5. Solving each of these, the first step is going to be to multiply both sides by 3. So we have 2x plus 1 is greater than 15. We're going to subtract 1 from both sides. So 2x is greater than 14. And now divide both sides by 2. X is greater than 7. We did not have to change that inequality symbol because we didn't divide by a negative. Looking at the next inequality, again, starting with multiplying both sides by 3, we have 2x plus 1 is less than -15. Subtract 1. 2x is less than -16. And then divide by 2. X is less than -8. I'm going to set up my number line so that I can set up my intervals a little bit easier. We've got -8 and 7. X is greater than 7, so that's values to the right of 7. X is less than -8. That's going to be values to the left of -8. My interval notation is going to go from -8, -infinity to -8. That one's a little tricky to write. Be careful there. Union 7 to +infinity. 2x minus, the absolute value of 2x minus 4 minus 5 is less than -10. Our first step is going to be to isolate the absolute value by adding 5 to both sides. So we have the absolute value of 2x minus 4 is less than, we add -10 plus 5, that's -5. And this is going to yield no solution because our distance can't be less than a negative number. absolute value of 7 minus x is greater than or equal to -4. Now, if we think of this in terms of what distance or what absolute value represents, it's representing distance. What this is saying is that the distance is more than -4 units. If we think about that, that's always going to be true. So I'm predicting that our solution is going to be all real numbers because distance is always going to be greater than a negative number. But what happens if we actually just set this up to see how we would solve it? So this is absolute value is greater than a value. So we would write this as 7 minus x is greater than or equal to -4, or 7 minus x is less than or equal to +4. A good way to remember this greater than situation is you keep the inequality, keep the sign of the original problem, and then you change the direction of the inequality, change the sign of the original value. So I have taught students the idea of like keep, change, change, and that's how we set up those two inequalities. But you do have that rule to reference. So now solving both of these inequalities, I'm going to start by subtracting 7 from both sides. So we have negative x is greater than -4 minus 7 is -11. Dividing both sides by -1, flipping that inequality symbol, we get x is less than or equal to 11. Or now we have to solve the second inequality. We're going to subtract 7. So negative x is less than or equal to 4 minus 7 is -3. Dividing both sides by -1, flipping that inequality symbol, we get x is greater than or equal to 3. And if I graph these on a number line, 3, 11, the first one says x is less than or equal to 11. So that's going to be values to the left of 11, including 11. The second one is x is greater than or equal to 3. So that's values to the right of 3, including 3. Or implies the union. So we're looking at all of the values included in either of these solutions. We can see that we have the entire number line shaded. So that is all real numbers or negative infinity to positive infinity.